Alright, so this is section 7.2, which is on the least squares line. So let's suppose we have random variables x and y. They satisfy the linear relation. Satisfy the relation. Suppose y equals to beta 0 plus beta 1 times x. So this is the equation of the line in the plane. Then our goal for the section is to figure out, or at least to get an estimate for beta 0 and beta 1. So first we obtain samples. Sample x1, y1, x2, y2, all the way to xn, yn. So ideally, these samples should satisfy yi equals to beta 0 plus beta 1 xi. But samples come with measurement errors, so epsilon I is the measurement error. Okay. Beta 0 and beta 1 are called the regression coefficient. And if you know stuff about lines, the beta 0 is technically the y-intercept, and beta 1 is the slope of the line. Okay, so this is called the true line. So beta 0 and beta 1 are true y-intercept and slope that we were trying to figure out, but often we can't. So we take for alternatives, we try to find an estimate. So the alternative is we will find an estimate for the line, which is yi equal to beta 0 hat plus beta 1 hat xi plus ei. So beta 0 and beta 1 hat are called the least square coefficient, and ei is called the residual. And this equation with the estimates is called the least square line. Okay. So everything with the hat in the bottom is to use to estimate the true line. Right, so let's draw a picture here. So to make things easier, let's suppose we only have 3 points. So x1, y1, x2, y2, and x3, y3. And suppose we want a line that looks like this. So this is y equals to beta 0 hat plus beta 1 hat x. Okay, so as you see, the 3 sample points do not lie on the line, so there's going to be some errors. So let's introduce some terminologies. So for x1, y1, if you map it down, this is called x1, y1 hat. So y1 hat is equal to beta 0 hat plus beta 1 hat x1. So this is called a fitted value, which means this is the value with the same. So this is the y value on the line, on the least square line, corresponding to x1. Okay. So y1 hat is equal to beta 0 hat plus beta 1 hat x1. But if you recall that let's say y1 is equal to beta 0 hat plus beta 1 hat x1 plus e1. E1 is the residual. Then we get, if you take the difference between these two equations, this equation and this equation, then we get y1 minus y1 hat is equal to e1. So this means this vertical distance here is e1, which is how far. So e1 is the vertical distance from x1, y1 to the least square line. And then same thing, we have E2, so this tiny thing is E2, and this is E3. Okay. So the goal is to minimize the sum of EI, but because EI could be positive and negative, so a common practice is to make everything positive. So we take the squares of all the EIs and add it together. So the goal is to minimize the sum of EI squared. Okay. So EI, the sum of EI squared, I equal to 1 to n, is equal to I equal to 1 to n. EI, remember, is equal to yi, look at this, minus yi hat square, and this is equal to, I might write from 1 to n, yi, and yi hat is beta 0 hat plus, which turns into a minus, beta 1 hat xi, the whole thing square. Okay. Okay, so we want to minimize this quantity. So we want to choose, we want to find beta 0 hat and beta 1 hat that minimize this quantity. Okay, so there's some calculus involved. I'm not gonna go into all the grand details, but the idea is that you first, there's only one process. If you want to minimize this quantity, what you do is you take the partial derivative with respect to either of them. So you take the partial derivative, and with respect to beta naught hat, you take the partial derivative with respect to beta 1 hat, and then set to 0 and set to 0. So you want to find a minimum, and you take the individual partial derivatives and you set them both equal to 0, and after a bunch of calculations, you'll figure out that beta 1, if you solve for beta 0 and beta 1 is going to be equal to the sum from I equal to 1 to n, xi minus x bar, yi minus y bar, over the sum of I equal to 1 to n, xi minus x bar squared. Okay. And this looks very similar to the value r, which is the correlation. And similar to that, this has an alternative formula. So this can be calculated. You can calculate the sum of xi, yi's first, and then minus n x bar, y bar. In the denominator, you can calculate the sum of square xy squares first, and then minus n x bar squared. So this is the value of beta 1, and beta 0 is equal to y bar minus beta 1 hat x bar. So this is how we solve for least squares line. Okay, so the least square line has two different kind of representations. You can write it in the slope intercept form. Then it's y equals to beta 0 hat plus beta 1 hat x. Beta 0 hat and beta 1 hat have formulas above. And an easier way to express this is the point slope form. So the point that is going through is x bar, y bar. So and the slope is still beta 1. So we have the equation of the line is y minus y bar equals to beta 1 hat times x minus x bar. So the point, this goes through the point x bar, y bar. Alright, so this is how we figure out the equation for the least squares line.